Hello everyone, and welcome to today's Data Hub series episode, Interoperability, the Cooperative Approach. My name is Areti Daradimu. I am the Content Director for Data and All Things Digital for Enlit Europe, and I am happy to introduce today's moderator, Mr. Willem Strabing, representing ESMIC. Hello Willem, and welcome to this data episode hosted by Enlit Europe. But before I hand the mic over to Willem, I have a few things I would like to cover about today's episode. First, today's episode will be available on demand after the live sessions on the Enlit Europe website. Next, we'd love to hear from you throughout today's episode and during the presentations. If you have a question for our speakers, please feel free to send it through the Ask Staff a Question box on the right side of your screen. We'll be answering questions during today's session. If we don't get to your question during today's episode, we will try to follow up afterward. And last, we'd like to encourage you to share today's webinar with your social networks. Therefore, tweet away. So without any further delay, Willem, over to you.
Yes, thank you very much, Areti. I hope you can hear me, so I have all the buttons pushed in the right way. Good morning, all. Thanks, Areti, for the nice introduction. Also a warm welcome from my side at this interesting webinar. Today we will talk about smart metering and the lessons learned regarding interoperability. That can be an example for solving interoperability issues in the wider smart grid and even for other applications around. I would like to show some examples of groundwork that has been done through expert teams in Brussels regarding interoperability, just for a start to know from your side. So what is done before? And if I can ask the organizers to put on the first sheet, you see here the covers of two reports, some results from a group called Expert Group 1 under the Smart Grid Task Force of the European Commission. First of all, one of these reports shows an overview of the implementation of interfaces for consumers in Europe to get metadata directly from the meter, from a smart meter, and the communication standards that are used for this interface. The scope of this study was including gas meters and electricity meters, so not really multi-commodity, but at least two commodities covered. An explanation, the second report is an explanation of how to reach interoperability using existing communication standards. So what to do on top of selecting a standard in order to reach full interoperability. Then on the second slide, if you can move to the second one, is another study, the cover of another study that was done. I think it was about 2 years ago on interoperability standards that can be applied for demand-side management in demand-side flexibility. The diagram that you see on the screen shows the reference architecture that was used to identify the relevant standards and the relevant interfaces and standard applied for those interfaces. And important to note here is that the focus in this study was electricity demand, and an overarching ontology called SARA for Ener was playing a key role in this study. So just to give you a little bit of information on work that has been done in the last years on interoperability for smart metering, interoperability for demand-side flexibility. A lot of groundwork has been done. We have seen that standards are existing, but in order to reach interoperability, you have to do a little bit more than just selecting a standard. And that's what we will explain also today. What is the work that has been done in the area of smart metering in order to reach full interoperability. We have nice presentations, both from project work, from real projects, but also from technology development, standards developments, and what is all around in order to help you in reaching a full interoperable architecture. Our first speaker I would like to introduce is Davy Michiels. Davy is working at the Belgium distribution system operator DSO Fluvius. He joined Fluvius in 2010 after a career in mobile telecom networks. He has been managing several big change projects in Fluvius around smart metering and smart grids. And nowadays, Davy is responsible for the current smart meter rollout program at Fluvius, and he will tell us more about this in his presentation. So, Davy, I cannot say the floor is yours, but the video channel is yours. Welcome.
Thank you, Willem, for this introduction. Everybody, welcome to the presentation. So following the introduction of Willem, I will talk through the Fluvius case, which fits in today's agenda. So we'll zoom in the smart meter project, which we are running at Fluvius, to really highlight the importance of interoperability as such. So first of all, on the next slide, we can see what is Fluvius about. So Fluvius is a DSO, distribution system operator in Flanders, so the northern part of Belgium. We are a multi-utility company, and we were established in 2018, in fact, as a merger of the former Eandis and Infrax companies. So as Fluvius, we are serving the whole of Flanders, so 100% of municipalities are connected. In total, we are talking, as you can see on the figure, about 7.3 million connections, multi-utility. Yeah? We really want to be and we are working towards to be the reference multi-utility company in Belgium. So electricity is, of course, the biggest part, 3.5 million connections, but we are also having 2.3 million natural gas connections and also other activities like sewerage, internet connectivity, public lighting coming on. And I will also talk you through on future evolutions, for example, in the direction of water distribution later on. At Fluvius, our mission is really to sustainably connect the society through our multi-utility solutions. So we see as part of the energy transition, things are evolving, things are changing. We want to do it in a future-oriented way, in a sustainable way. We want to be the player enabling connected grids in all terms to allow the energy transition. And there, multi-utility and interoperability really comes into the game. On the next slide, bring you to the case we're really talking. If you click, okay, yeah. Yes, thank you. Once more, please. Thank you. One slide back. Thank you. Yes. So the case we were talking about today is our rollout of smart meters, which we have started in 2019. So the scope for Fluvius at this moment is to replace and install 6.1 million meters by 29. It's devised over majority electricity and gas meters on 2.3 million. Important to know is that to enable the energy transition and based on legislation, we have a fast start, and we will have executed 80% of this volume by the end of 24. So that means that 80%, 4.8 million meters, have to be replaced by 24. This is an increased target we recently started working on. So this really is also one of the drivers to really work towards interoperability. We have done many pilot projects in the past where we learned a lot. And we had based in 2017 and 18, we made some strategical choices which we embarked on. And we are now really working on getting this realized in a high-speed exercise. Okay, if we continue to the next slide. The approach we have chosen is after a lot of pilot project where we did a lot of technical tests. In 2017, we made a strategical choice to use ID specification-based smart electricity meters and OMS, open metering specification-based smart gas meters. This was really a key important choice for us. Fluvius, Belgium, not being, let's say, the biggest market within Europe, and certainly not on a global scale. Okay, we have 6 million meters, but that's a small country compared to some other European countries. For us, it was really key to choose available standards and specifications and not to reinvent the wheel ourselves. For us as a utility, it's really important to have access or use reliable, easy to install products. And when you embark such a rollout, when this really impacts this new type of smart meters, when this is bringing to our business, to our customers, it really needs to be efficient in rollout, operational wise with technicians, efficient in supply chain. the handling should be as easy as possible by technicians, and interchanging devices should not be limited by technical constraints. You cannot bring on technical reasons on communication or protocol standards to communicate with technicians that product A or product B is not compatible. So that's really very important for us to realize a smooth rollout. If we turn the page to the next slide, that brings us, I will highlight the importance of interoperability, but importantly to state is that for Fluvius, interoperability as a technical element is not a goal on itself. For us, interoperability is a way to achieve our business goals. And the business goals which are there around in this area are, as I put some examples on the slides. Customers, they need different type of connections, which means different type of meters. I think about single phase, polyphase meters, without gas, with gas connections, without gas connections. So there is a flexibility needed in what we need to offer to the customer, and also over time things might change. Customer might purchase an electrical vehicle which might increase his electricity consumption, and that might influence the type of connection. So we really need to have flexibility in the type of meters which we offer in terms of connections. The energy transition also for us means that we need to have a combined approach of at least electricity and gas. We are bi-fuel DSO, but we really see also in terms of energy transition that the combination of at least these two, but in the future possibly more energy types is really key. So we cannot handle one without the other. I already highlighted that technicians, they should be able to handle those different types of models of meters. So it's a multi-vendor strategy. It's really a crucial element to reach our goals, which also means that on that level, it needs to be as easy to install, and interoperability is also there important. And last but not least, the data coming out of those smart meters, because smart meters are being read to use the data for billing and grid management. All this data, whether it's coming from different types of meters, need to be transparent and needs to be flexible to be used in our backend systems and market systems. So it means that the technology, the meter technology should really be the enabler to realize those business demands. So the interoperability as such is not our goal, but interoperability really serves that we can drive our business and run the business to reach our goals, which I've highlighted in the beginning, being 80% rolled out in 24. Now, if we jump on the next slide to a little more technical insight. So specifically, we have been working a lot on the interaction case between smart electricity meters and smart gas meters. That is really the key element of our smart meter rollout. The electricity meter serving as the communication hub towards the head-end system, central head-end system, and linking using the MBus, wireless MBus protocol, linking the gas meters. Now, we have chosen standards there. I already highlighted our choice for IDIS in the past and OMS. Towards the future, currently in 2017, we made a choice for the previous version, and I think the colleagues will come back in the presentation next to this one. We started with IDIS package 2. In the meantime, we decided to continue with future meters to use the package 3 related to increased functionality and better standards. And also on the OMS level, we decided to follow the latest version being the 4.2.1. You already see there that on the OMS part, we also mention water, because we don't want to limit this solution to only have electricity, gas, but we are also opening it up to water meters. Now, standards are there. There are devices, there are electricity meters, smart gas meters, incorporating these specifications, incorporating these standards. But we learned quite some hard lessons, and interoperability really requires thorough testing. And the interoperability is not limited to the lower physical layers and having certain things defined, but the importance is to have use cases defined on a higher level, application level, and even above, because the main crucial thing is the interoperability between the three building blocks which are here on the screen, starting off with the central AMI head-end system, then the electricity meter IDIS DLMS based, and then going through the sub-meter, the gas ambus meter, for example. It's really key that you don't limit your testing or your setup to technical message, but you really start off listed use cases, because it's mainly those use cases. They are typically a sequence of activities which needs to be carried out in a correct order. And it's really the sequence, the order of things which needs to be assured. And for that, it's really important to rely on use cases. And that's, for us also at Fluvius, one of the important things in the available conformance testing, both on the IDIS, but also being built on the OMS part, is that this testing on a more use case level is really the key thing to verify, because it's this what makes the difference, and this will make that you can, as a DSO, run your business end to end. That you are able to collect data from electricity meters, which on their turn are linked to gas meters, and that for the different cases, everything is defined. So don't limit testing or verification to certain messages or on the physical layers, but really go into the more complex use cases. And indeed, they are complex. It's not an easy task. There is a lot of work ongoing. We are collaborating since quite some years with both IDIS and the OMS. The colleagues will talk later on that. It's really by collaborating, by working together, that we can enhance the specifications, and in a later sense that will also, this increased quality will also contribute to better products which serve the demand of the customer. So that was the main message I would like to bring on this. We will continue further on in the presentation by the colleagues on this topic. If we have a look at what brings the future, we can, I think, jump to the next slide for that. The future is tomorrow. In fact, I would even say the future is today. We need to really start preparing the future of our connection grids today. And honestly, I think like most colleagues, we are already working on that since quite some time. More specific, what we'll do in the smart meter rollout, there are two main, let's say, extensions we are working on. Is on the one hand, we will add smart water meters in collaboration with the local Flemish water distribution companies. At the moment, we are embarking their first pilot tests, but we will work together and in order to realize rollout synergies. And when you need to go to customers to install meters, you have quite some synergies which can be realized there. But specifically for the water meter, being another type of an ambus, OMS ambus water meter, we also can optimize our communication network usage. So it's really this choice there to keep on using the smart electricity meter as a communication hub. But also important in that story is by bringing the smart water meter together with smart electricity, smart gas, then it means that the customer, the end customer, really gets a total view, an overview, a good customer insight into his total energy consumption, including water. And that's really an important evolution we have seen and we will embark on. The next element is that Fluvius, being the Flemish DSO, Belgium also consists of two other regions. We have Brussels and we have Wallonia, the southern part. We also have started recently in collaboration project with Ores, Reza and Sibelga, so the leading DSOs from the other Belgian regions. And the rollouts have started there using the same technical solution. So also there, those companies are now following the choice for the IDIS OMS interoperable solution. Goal is really there to leverage our existing technical solution and to streamline the supply chain. So it's really becoming the Belgian solution, which will in the end increase the volumes even more. As a conclusion, I can say that all those elements together, interoperability as a base layer is there to really realize the business demands, and this interoperability for us as DSO allows us to extend the solution by adding other types of meters, can be other types of electricity meters, can be other type, for example, the water meter. So it means that we are not stuck at a certain point, that the solution can grow, and what we are actively showing now. By doing this, we also make our supply chain resilient, because having this high number of meters installed in daily operations really requires an optimal supply chain and logistics chain, and thus requires also a multi-vendor approach. And that's really also there where interoperability comes into the game. And last but not least, using these standards, we are also able to extend our portfolio of services and the asset management of those devices in a more structured way, because it's really built on a clearly documented set of standards. So that's really our conclusion at Fluvius. By making this choice, this OMS-based interoperability is really the key to drive our business coming years. Okay, by this I would like to give the word back to Willem to continue the presentation of the dear colleagues, and we will zoom in on this more. Please don't hesitate to raise your questions to the question box, and you find my contact details here for further follow-up. Thank you very much.
Okay, thank you, Davy, for this interesting presentation. Perfect. Good that you mentioned. So again, also for the audience, please enter your questions in the list. In the end of the webinar, we will have a 20 minutes Q&A. So we will then try to answer all your questions that you might have to get more information about what we have presented. Thanks again, Davy. Now we will continue with a presentation about the interoperability approach by several standards and providers associations. There will be 3 speakers for this presentation, and let me introduce them. First, it is Peter Kudze. Peter started his career in AEG Research and Development in South Africa. Then he relocated to Europe to head up Itron's global IEC electricity portfolio, coinciding with early years of smart metering deployment in Europe. He currently manages market and business development activities for Itron across EMEA and Asia Pacific. And he has also been recently elected as the president of the IDES Association, already mentioned by Davy. So Peter, if you can get your camera on, then people can see you. Second speaker is Tony Field. Tony is chairman of the board of directors of the DLMS User Association. He has worked in the smart metering and smart grid space for over 18 years, holding positions in manufacturing engineering, project management, and marketing. Currently, Tony is working for Itron within the Strategic Standards Division of Technology and Research. Welcome, Tony. Third speaker, Charles van Dijk. Charles is responsible, or has a responsibility in smart metering solutions at Apator in Poland. He has over 30 years experience with meter equipment for the utility industry in Europe, and has been involved in the smart gas and water metering in Europe from the very beginning. Charles is currently marketing group leader of the Open Metering System Association, OMS, also already mentioned by Davy. So welcome to the 3 of you. I'll give you the video channel and go ahead. Thanks and welcome. So maybe we can get the first sheet of the presentation of Tony, Peter, and Charles. Yes, thanks. So go ahead. I think Peter is still on mute. If one of the others wants to start, then fine. But it's good to have the 3 of you, so at least one of you can start talking.
There we go. I think I've been unmuted by the organizers.
Yeah.
Can you hear me, Willem?
Yeah, we can hear you, Peter. Welcome. Yeah.
Excellent. Thank you very much. Good morning, good afternoon, everybody. So just a bit of history here. We're going to talk specifically about how IDES, OMS, and the DLMS User Association supports interoperability and supports interoperability specifically towards the Fluvius mass rollout. So going back slightly, things started in a bit of chaos. Initially, when we had electromechanical meter and then slowly the emergence of static metering, there wasn't so much a need for interoperability, because interoperability at that stage was pretty much just eyeball reading of meters. So ultimately you did have replacement of meters, so no real interoperability required. As static metering and smart metering started emerging, it was clear that the need was required for meters to start consistently communicated in the same way from an end-to-end basis. And that's where in 1997, the Device Language Messaging Specification User Organization, DLMS, was started to start creating a bit of order from this chaos. This transition to standardization of the data models, functionality, and common vocabulary was really accelerated with specific wording in the January 2009 European mandate, which asked for the support of enabling interoperable open standards. Now, as everybody knows, standards are not, and it was mentioned by Davey as well, standards is not enough. Standards is good, but there's a lot of choices to make. And this is where, from a playing field perspective and down to the specific options, choices and decisions has to be made. The effect of too many choices is really self-evident. Ultimately, you don't really have interoperability and things don't really work too well together. So this is where interoperability, this culminates ultimately in high cost rollouts and a lot of customization for suppliers, for vendors, and ultimately a project that's exorbitant in terms of cost. And this is where IDIS, with the support of OMS and DLMS, was really born. It was a direct consequence of the too many choices in the market. And the idea was to start making specific decisions on what options and specifications to choose from and how the use cases will work from an end-to-end basis for a smart metering rollout, as a direct consequence of the European Union mandate for smart metering. Now, to be very clear, IDIS is not there to create new standards. It is there to make decisions and to make things work together. So we started from the device level upwards in order to create end-to-end use cases that creates interoperability. So next slide, please. So standardization.
Okay, so this.
Yes, Tony, please go ahead.
Okay, sorry, Peter. So this slide shows a simplified picture of the relationships between the SDOs, the standardization organizations at international, regional, and national level, and their interactions with each other, the associations, and the parts they all play in the story of interoperability. And I'll talk through very quickly an example of how that works with the associations represented today. So through various liaison relationships, the specification development associations bring in market requirements and contributions to the top level of standards, in this case DLMS COSEM and MBUS, which are combined with and approved by country level membership representation in the SDOs and the various technical committees such as IEC, CEN and CENELEC. The finished standards are then published by international, regional and country development SDOs for anyone to use. And the specification development associations also absorb technologies from other SDOs such as IEEE, IETF, ETSI, to enhance and update the specifications, allowing the use of the latest technologies while keeping a rigorous approach to using proven standards, based technologies, and not reinventing the wheel. The specification development associations are usually responsible for providing conformance certification against their specifications. So the associations then narrow down the vast array of features in those core standards to a subset known as a companion specification, such as IDIS or OMS. And the companion specifications makes these selections of the many optional features, as Peter mentioned earlier on, allowing the delivery of a certain discrete set of business processes and use cases, which are then certifiable for interoperability, both from a communications perspective and in some cases a functional perspective as well. So this process is a little bit like creating a recipe and it will allow you to make a specific dish. The companion specification certifies the product for conformance against the features of that particular set of use cases. Sometimes these stages are done in the same way, same process, by the same organisation. Sometimes it's through different organisations, depending on which standard you're looking at. For example, in the case of the DLMS COSEM, the specifications are prepared in the user association, and then through a C-type liaison are then published through IEC TC13 Working Group 14. The user association certifies conformance with the DLMS specification. To use the recipe analogy, it certifies that you've properly constituted flour, eggs, butter, and salt, but does not certify that you have made a cake, a sauce, a pancake, a loaf of bread, or a chapati. The IDIS association, or whoever's responsible for making the companion specification, then goes and certifies the interoperability profile with the corresponding tools and the standardization building blocks and the use cases. And at that point, you really know that you've made a cake, and the cake that you were expecting, and everybody following the recipe will also make a same tasting cake. So that's kind of a brief overview of how companion specifications work with regards to core standards, and how those then relate into the SDOs and the wider picture of standardization by this cooperative relationship between the SDOs. So I think if we can move on to the next slide, we have an introduction of the associations. So the DLMS UA User Association was founded in 1997 by a small group of meter manufacturers who, at that time, recognised the need for an interoperable application layer protocol for smart meters. The association grew over the years to where it is today, with a membership of over 250, consisting of system integrators, utilities, and meter vendors alike, while all the time, over these 20 years, still maintaining backwards compatibility in the standards to ensure security of investment by the members. The user association has relationships with several regional and global SDOs, as we've talked about, notably IEC, and the association provides the testing and certification tools for its conformance certification, allowing members to then use the conformance mark on their products. So if I hand over to Peter, you can introduce the IDIS Association.
Right, so as mentioned, IDIS was specifically formed in the post-2009 mandate. So in 2010, the manufacturers got together, a small group at that time, to make decisions and focus on use cases from an end-to-end basis. So as Tony already mentioned, we use the recipes or the ingredients defined by DLMS COSEM, as well as OMS recently, and we specify specific use cases from an end-to-end perspective of how things will work. In addition to this, the IDIS methodology and IDIS approach, the whole IDIS system, really supports certification testing of devices, as well as interoperability testing, where we put devices next to each other and then remove them and essentially prove the system from an end-to-end perspective to ensure that things work together. Charles.
OMS, the third one, founded on request of utilities, and still utilities are active in our organization as members and in working groups. Fluvius, by the way, is one of them. We have a focus on battery-powered devices, and we have to guarantee lifetimes of 15 years or more, with communication frequency of from 10 seconds to 5 minutes, and we have proven that this is possible. We have an enhanced security compliant with very demanding national specifications, and like the German BSI. OMS has developed their own compliance tool available for product development and certification. Certification is possible by third parties like DVGW and TÜV in Germany. Members work together in working groups, and that is essential, and develop the future standards. And you are all welcome to join. So, next slide, please.
All right, I'll talk a bit about this. The intention of this is to show how these associations that were just introduced now, supporting Fluvius from an end-to-end perspective. So sort of a simplified architectural diagram. Starting at the top there, really, the focus of the companion specification that supports Fluvius rollout is, as Davey also mentioned, really all about the application layer. So IDIS package 3 defines an internet protocol-based application layer protocol, and the lower physical and network layers are really coming from the cellular technology, specifically the 4G, fourth generation cellular technology. So narrowband IoT, M1, LTE M1, that's been rolled out now in Belgium. Under this, specifically, a package 3 makes provision through a collaboration with the OMS group to accommodate slave meters as well. Currently, the specification or the rollout, the profile specification for Fluvius allows for 4 different devices. This could be extended as well. And specifically, the focus of the initial project will be a gas meter as a sub-meter. But there's also, as Davey specifically mentioned, provision for water meters, electricity sub-meters, as well as heat meters. So another thing to note here, security overlaying this is based on the DLMS profile, Suite 1. And a couple of things to note from a use case perspective. This is a 15-minute profile, so very much looking at where the European Union, where Europe, and pretty much the world is moving towards electricity metering, where 15-minute profiles are becoming the norm. In addition to that, it's a disconnect, reconnect use cases. So there is disconnection at both the gas level as well as the meter level. And very important case, Fluvius did a lot of work in terms of making a light or a no-touch deployment scenario here, where the installation of a meter is really done with very limited tools or no tools at all. And the technician goes into the field and things happen pretty much seamlessly. So part of the end-to-end use cases and the interoperability testing is defining those use cases that will work during the installation process and how things fit together. Next slide, please. So a bit on the superset of use cases that's currently supported within IDIS. Remember, IDIS is not creating anything new. We're not an association that creates standards, but we make selections. So currently there's a superset of 13 use cases that we support. And this is as a direct consequence of utility demand, of market demand. So a couple of things to note. Package 3, the recent one, started incorporating battery-powered wireless devices, specifically with the collaboration of OMS. We added things like enabling communication through to end customers through the end customer port. We had things like load management by relay, strengthened through overlaying new selections of security profile. So that superset of 13 use cases is really future focused. It accommodates best practices, what utilities and what's demanded by consumers and consumer groups. And we've been really focused towards the next 10 years of applications from a European perspective, but also more notably from a global perspective also. Charles.
So for OMS, you already heard from Davey what some of the use cases, but how important the use cases are. And this is just a list of use cases for Fluvius. Of course, for other applications, we can have completely different ones. Fluvius works from the so-called C1, T2 mode. That is every 5 minutes there is a real-time value package sent to the hub for customer slot for the customer information, and there is a quarterly send of package with a stored hourly value for the head-end system. Then there is, when we have this quarterly value sent, the so-called T1, we have a possibility for a T2, for instance, for changing valve position. So we have, I give you, you see the list here. We have an example of the use case of the valve. The valve can be opened remotely or released, not opened remotely because of safety reasons. And it has to be opened by customer interference. We can offer really much more than we show here. And when you consider multi-utility with our joint standards, then we are always happy to advise you with your use cases. Next slide, please.
Seems we have a problem with Tony. Just got a message from him. He's got an issue with his network. So let me take this one. So specifically, we just wanted to focus a bit to show everybody how practical the system or the profile is that we've currently selected and supporting with Fluvius for the rollout there. So we've got 3 examples, a bit more detailed examples of use cases. The one is meter registration, then meter reading, and then specifically we look at firmware upgrade. Now, I'm not going to go into the technical detail of how this fits together, but the important messages here are that we've defined from a wireless M-bus perspective for the submeter. We've decided exactly which objects to use, how that fits together, and how the gas meter pairs up with the electricity meter through the M-bus connection. From there onwards, upstream, we communicate through cellular on a DLMS COSEM profile that was defined specifically for meter registration, with the details that everybody can see in this slide. Charles, I don't know if you want to mention anything specific on the wireless M-bus side.
Well, I think it's okay.
It's okay. All right. So we go on to the next slide, please. Right. So this is intended to show meter reading. Again, the pairing, once the registration of the M-bus device, the wireless M-bus submeter, is tied up with the electricity meter, those values are sent to the electricity meter from the M-bus device and ultimately read via DLMS COSEM use cases in different profile registers through the upstream link, the IPv4, IPv6 upstream link. Next slide, please. And the last one, which is absolutely not the least, is all about firmware upgrade. Now, we have made provision for both upgrading firmware from the M-bus device perspective, as well as from the electricity device perspective. The important message here is ultimately, this is a long-term investment. Things will change. There will be updates required. And the profile selected to support the Fluvius rollout allows us to manage both slave devices or submeter devices, as well as the main electricity meter. So Tony, I see you've joined. You can keep me a bit honest here and maybe add something to that.
Yes, apologies for that. My computer just decided to crash at the most inopportune moment, as these things always do. So yes, this process really leverages the close relationship between the DLMS COSEM application layer protocol as well as the M-bus application layer protocol. And it really sort of mirrors the functionality whereby information taken from the M-bus device is then modeled within the DLMS COSEM objects model. And there's a completely seamless process between the data being gathered from the meter and then that being presented to the head-end system in a native DLMS COSEM format. And this particular example shows the process of taking the firmware image, it's then wrapped up, it's then sent natively in DLMS COSEM as a blob. Then the process for transferring it across the wireless M-bus network to the electricity meter is then monitored through the DLMS COSEM domain, and at the various stages of download, of verify, and of execute, the status objects within the DLMS COSEM model are then updated so that from the head end, all of this process can be monitored without having to then go right the way through to the M-bus end device, because this is all controlled using the DLMS COSEM model. So that's pretty much what I wanted to say about that. And I was listening in on audio, Peter, and your descriptions of the other use cases were good too. So I think we can move on to the next slide.
Thanks, Tony.
So the next one is the benefits of the Fluvius approach. So Fluvius has clearly chosen for the multi-utility approach. One communication channel for all the utility meter devices to one head-end system, sharing the cost of the service. In this multi-utility approach, our standards have experience during 10 years in the real world of deployments, and since 3 years in a harmonized way. Millions of devices have been deployed globally following the underlying standards. companion standards are developed in collaboration, like Fluvius. We all developed tools for compliancy and enable certification by third parties. Our recommendation: do not reinvent the wheel. You have heard it now 3 times, and here it is written, and use available and proven systems. This was the last slide, and the next one will, please, the next slide, please. Next slide. Yes, and there we thank you for your attention. And Willem, can you pick it up?
Yeah, I hope everything is working again. Thanks again, Peter, Charles, Tony, for this presentation. Very good to have the insights in how these different 3 associations are supporting the work on interoperability. Thanks again. For the audience, again, I have seen that some questions are coming in, so very good. If there are more questions, then please don't hesitate to put them on the chat box. We will answer those questions in just a few minutes from now. On the program, we now have a panel session, so we will go through some discussion topics together with Peter, Charles, and Tony, and Davy. And then after that, we will still have 20 minutes for answering your questions, so we'll come back to that. Good. Okay, thanks again for your presentations. There are a few topics that we would like to discuss with all of you. And the first one is, you already mentioned testing. So testing is one of the important steps to take in order to reach interoperability. Knowing if implementations comply to standards, you can do conformist testing. The question here is, so we have those testing procedures. Is that complete? Is it sufficient? So suppose you have done a conformist test of one product, and then you want to connect this product in a larger infrastructure. Is then a product certificate sufficient? So what is more in there regarding testing? Maybe you can explain a little bit more on that. Whoever wants to take the floor.
Maybe from a DSO point of view, I can open the discussion on that. So is it sufficient? Not as such. We consider it as a first starting step. It's not really the only first step, but the certificate is really the proof that the product which is at hand is really compliant to what the standard specified. But at that moment, we really start in more deep dive interoperable testing, and we will start using, or we really know from experience, it's important to start using those meters in different business scenarios, get your technicians in, or at least key users, to really, I would say, play with it, but to test and verify a combination of series. The use cases which have been showed are really good, but in reality, in real life, these things don't happen, let's say, in a fixed series. It really depends on your business scenarios. It depends on your customer scenarios. So for us, the product certificate is a starting point. At that point, afterwards, you can continue with more business acceptance testing, like we often call that. But it's a minimum to achieve, to start that.
Good. Thanks, Davy. Tony, Charles, Peter, any response from your side?
Yeah, maybe just a comment from an interoperability testing point of view. So I mentioned what we've learned from a best practice perspective is there's a conformance testing, which is a one-on-one device testing. And what we do is we run through a set of a test tool with a specific device and sign it off in terms of the behavior of that device on a one-on-one basis with a software test tool. In addition to that, what's really also fundamentally required is in-field interoperability testing. And this is where we put the devices next to what we call golden samples, essentially sort of reference devices, to ensure that you have full interchangeability and interoperability. Because it's always the little things that will trip you over. If you have timing difference between devices, if you have to have issues on how a specific use case was not 100% correctly implemented, those will trip you off during a field interoperability testing. And that's one of the clear recommendations and one of the processes that we take through the IDIS devices as well, to what we call a FIT, field interoperability testing.
Okay, thanks. Before we go to the next point, is there anything from Charles, Tony, to add?
Maybe a bit from the OMS point of view. We have a lot of experience with certification in the German market, where OMS is also used for the sub-metering market, and where we have clear use cases, and where a lot of devices have been certified following a clear structure, a clear protocol, and that works very fine. When we work with a more complex model like Fluvius, then of course we have to make our tools fit and the script fit for this specific case, and but should always be possible in the end. That is what I wanted to add.
Okay, thanks. Good. Okay.
I would just only add.
Yeah. Tony?
I'll just add that if you're looking at performing interoperability, the associations make it look easy by providing certificates and having a process, but don't underestimate the cost and the time that this would take if you were wanting to start from scratch and reinvent a standard or reinvent an interoperability profile. It is very difficult. There's a lot of hard yards to go from a document and a piece of paper to fully interoperable products, and just don't ever underestimate the cost in money and time and human resources that it takes to follow that process to completion.
Okay, perfect, thanks. Good. Next point to discuss is, we have seen in your presentations that standards are available. So you have talked about DLMS, you have talked about MBus standards for the connections between meters and other systems. We have seen a very good example from Belgium. Davy has explained how Fluvius is using those standards and have implemented them with success. So what about other countries? Countries inside Europe, countries outside Europe. Do you see really a good coverage of these standards being used, or are there competitive competitive standards, competing standards? What can you say about that?
A comment from the IDIS side. One of the reasons why we're selecting existing mature standards is exactly because of that. We believe that we need to collaborate with associations that evolve the standards and incorporate new future-looking and enhancements to those standards without reinventing the wheel. So basically building on what was learned. The DLMS COSEM as a standard started emerging in the late 90s. It's pretty much become a de facto standard used pretty much everywhere in the world today. There was recently, DLMS is also now in the US, incorporated into an ANSI standard. Portions of DLMS is used throughout Latin America, as well as very broadly in Asia Pacific. So the simple answer is, what we've defined here from a use case perspective, based on a set of existing standards, is applicable globally. Tony, you want to add maybe to that? Quick comment on that?
Yes, absolutely. Particularly in the DLMS COSEM example, the association has always been of the position where the application layer is completely independent and agnostic to whatever it's being transported over. And over the 20 years it's been in existence, it has adopted all sorts of technologies from other standardization organizations that are proven technologies for transporting any type of application layer protocol. And DLMS COSEM has exactly the same application layer, no matter how it's transported and over what media. It's just a very sort of simple process of creating a profile for how DLMS COSEM interprets that particular media. But the important thing is that the head-end configuration doesn't need to change because the data model is the same. The use cases can be completely consistent regardless of whatever lower layer it is. And as I mentioned in my presentation, it has these relationships with other SDOs to absorb these technologies as time moves on, as communication technologies move on. In the cellular world, outside of the cellular world, with mesh radio, with low power WAN, whatever it is, all of those can be absorbed so that the application layer can remain consistent. Okay, thanks.
So we can see that we all have a track record individually, but in a multi-utility project like Fluvius, this is relatively new. We started our cooperation some 3-4 years ago, and now since 3 years we have a complete set of standards for multi-utility setup, and that is relatively new, and I really hope that we can use this set of standards in new projects, and not only in Europe but globally. So that is what I wanted to add.
Okay, thanks, Charles. Thank you for your responses on this point. Let's go to the next. What about the relation with upcoming IoT standards? So you see more and more IoT solutions are used for multi-purpose, coming also from other industries and used by other industries. So what about these standards and the relation with the standards that you have dealt with?
I think an important note that that Tony has already highlighted is that we're focusing very much on application layer when it comes to IDIS. So we not like DLMS. We initially started with a package 1, which was very much tied to a PLC generation 1 communication at the time. We learned very quickly that we need to evolve beyond that, because the cadence and the pace of development of underlying specifications, network and physical layer specifications, completely different from the upper layer. So we needed to decouple that and really focus at the higher layers. So as far as we're concerned from an IDIS perspective, there will be evolutions at the lower layers, like for instance the new LTE technology that's coming in to play. But IDIS and DLMS COSIM, which is based on, really remains relevant despite the introduction, or in fact complementing the introduction of new lighter weight or newer based IoT type technologies. Tony, you want to maybe just expand on that a bit?
Yeah, absolutely. You hit the nail right on the head there. As it's always been, the application layer from DLMS COSIM just remains consistent. It absorbs the lower layer technologies, whatever IP technology or non-IP technology will come in. You don't have to start messing around and changing the application layer or the data model just because you're running it over a different transport. So all of the end-to-end security remains consistent and remains very, very strong. All of the data model remains the same, and all use cases are implemented can remain identical regardless of the lower layers. So that's the way in which standards that are well layered and well thought out to start with can absorb new technologies and maintain their relevance in ever-changing times and keep up with the fast-paced world of the telecommunications universe that is always innovating and moving on at a faster rate than perhaps we're more used to in the traditional utility sector.
For OMS,
sorry.
Okay. Shall I go on?
Maybe to complete the third standard in this webinar, OMS is considering IoT very much, but I have to remind you that we talk about battery-powered devices that has limited capacity, and the wireless MBUS is very strong in this short-range radio systems, and when you want to have a near-time communication with a battery-powered device, then IoT is not always obvious, but we are looking at it. Davy?
Yes, from a DSO point of view, I really can contribute to this message. Like Peter said, it's really the layered approach, the decoupling between the physical network layers and the application layers, which is crucial. And it makes also for us, today in the presentation we've spoken mainly on the overall standard solution, electricity meter and gas meter, but also within Fluvius we are looking into, call it special cases, and where we use a variety of low layer other technical communication layers, Also, like Charles just mentioned, on the battery powered devices. But it's important there we stick on the application layer to the same standards and same data model. It means that maybe for certain types of meters which use another communication layer or battery powered devices, that not all functionality, not all use cases are supported, but those which are still supported are still fitting within the same data model. And so you avoid complexity, and we don't have a variety of application layers at the central system. So still would advise everybody to keep on, even with multiple technical communication layers, still use the same application layers as we discussed today.
And I think, David, that also lends into things like 4G moving to 5G, right? For instance, this will not be a problem for your application or your rollout concept that you have now, right?
No, indeed, and indeed there we also, in fact, we sometimes have told there was 2G, the GPRS, it's 4G. 4G, in fact, in 4G Fluvius now we are using the narrowband IoT, which is a specific subset of that will evolve into the 5G family later on. But in fact, it doesn't matter. It's the modem which is inside your device which needs to support that. But on the application layer, we say, okay, we remain with the IDIS data model, we remain with the use cases there. And maybe some of them are not supported in one of these technologies, whatever, that you have to administer, but basically it all remains interoperable.
Okay.
Okay, good, thanks. Since we have a list of questions coming from the audience, I would like to suggest that we switch to the last part of the session. And we also have prepared some questions that might be interesting to discuss again, but let's start with those that we have received from the audience. Let me go to number one question that we got. What are the interoperability challenges between the different versions of the standards during the large rollouts? E.g., recently installed smart meter electricity meter IDIS 2, Fluvius setup with communications hub combination needs replacement, and only the new IDIS 3 smart meter is available. Gas water meter and bus initially set up to communicate with IDIS 3. So there's this question about different versions, IDIS 2 versus IDIS 3, etc., and availability of implementations. An important one. So I think we have to turn to IDIS and MBUS. Maybe Peter and Charles, you can start with this, and maybe also others can add up.
So quick commentary on the IDIS side. IDIS package 2 and IDIS package 3 are very much related. Package 3 is an extension or an addition to package 2. So we haven't changed the underlying use cases or data model from package 2 to package 3. So ultimately, at a head-end system level and even at a metadata management level, your objects and your data, your use cases will work in the same way. Now, there has been some updates and extensions to the battery-powered support side, which I'm going to leave Charles to talk about a bit. And there's also been some enhancements on security. So there would still be a need for existing devices to, over time, migrate over to the same package, I would think, from IDIS package 2 going up to IDIS package 3. But again, this is something that's been incorporated in the standards, and we have the ability to do firmware upgrades over time, over the lifetime of the device. Charles?
For OMS, as long as we stay in the OMS 4 and we don't change the mode and the security, then we will be backwards compatible, and there will not be a problem. When we change mode, for instance, we migrate from the T to the C mode, then we have to think how we do that. For your information, OMS will support very much the new, relatively new C mode in the OMS 4 package, and the reason is that the power consumption of the communication only will go for savings from 25 to 50%, when it's just bidirectional communication, can mount up to 50%. And then, but the C mode is not compliant with the T mode. And then, of course, as a DSO, you have to take some decisions to how you manage this. And this is a bit. This is my answer.
Okay.
Is your question answered, Willem?
It was not my question, so I hope so, yes. But
Yes.
again, if somebody has additional, so the one that posed the question has additional questions, then please let us know through the chat. Tony, Davey, I don't know if you want to add to this.
Maybe one last comment from our side. I think mentioned already by Peter, the firmware upgrade functionality is a really key element in all of this. We over the past 10 years, we insisted on having this functionality both on electricity meter, but also on the battery powered devices. Worked very hard on that. I see now at these versions of the standards, it's being incorporated. And for us, this will be one of the ways to get out of the situation referred to in the question.
Yeah, good. Okay, let's move to the next one then. Thanks. Next one, I think we discussed it already partly, at least. The question is 5G, 5G telecommunication technology a new opportunity for connectivity for meters, or is it a challenge or an issue? So what does it bring, 5G? Who wants to answer that? So, yep, go ahead.
The first quick commentary on 5G is it is a transport layer, a lower layer protocol. So again, it shouldn't break anything at the upper layer. That's point one. Is it an opportunity? It's an opportunity, I think, if it brings a performance or a cost enhancement ultimately to a utility like Fluvius, absolutely. 5G in itself is more optimized for broadband and higher speed connectivity for all the good reasons, vehicle tracking, etc. So it's not necessarily optimized for lower bandwidth applications. That's the split of 4G. That's more focused on IoT type devices. But ultimately, from a standards perspective and from a chosen technology perspective, use case perspective, it's an opportunity if the mobile network operators allows it to be. Otherwise, it's not going to break the system. It'll just make things better. Davey, any comments on this?
No, I follow your argumentation. That indeed is the decoupling of the transport layers and the communication layers is really important. So it shouldn't break anything. It brings possibilities. We should pay attention, however, that new 5G modems and because they are focused on other types of use cases, don't bring in increased cost or increased complexity in a stationary type of device like a meter. So, but I think we have seen that also in the past in the 4G family, where then more low latency machine to machine. So that will come. And if the feedbacks I get in interacting with the standards organizations there is that, okay, the narrowband IoT type of family will be migrated into the 5G. So things will continue. It's an opportunity, but at the moment as Fluvius, we don't see an urgent need to jump on that train at this moment.
I think as a final comment is it's very important for any rollout and any for during a rollout contracting with people like or players like the mobile network operators to ensure that the service levels and the warranties are correctly in place, because smart meter rollout is a 10 to 15 year up to 20-year investment. And one of the things with mobile technology, as Tony also said, is it tends to evolve a bit quicker within that time frame. And one of the things that should be made aware of to utilities, or utilities should contract towards, is not to break, that the mobile network operator does not break the solution of the utility during the life cycle of the long-term project. But that's again a lower layer issue, and it's more around service levels and contracting than it is about technology.
Okay, good. Thank you. Let's move to the next one. Next question. Is there an in-home display or internet connection to the consumer? Can meters be made without a display? So there's two questions. Let me take off by answering this question, because in the beginning of the session, I have shown two reports from as I explained, an expert group in Brussels under the Smart Grid Task Force that has studied the implementation of interfaces on the meter where consumers can connect tools in order to get information directly from the meter. So that's one. We have seen that in a large majority of the member states, this interface is available, is foreseen. It's also called in many countries the kind of near real-time or real-time interface for connecting tools to the meter directly. It's for gas meters, electricity meters at least. And currently expert group 1 is also working on use cases for providing this type of information to consumers. And I must say that this is one opportunity, one possibility. The other possibility referred to in this question is internet connection. That goes through, in most of the European countries, goes through the grid operator or DSO that collects the data and then provides this data through central servers that can also be a neutral party in some countries, a neutral data server where historic data is collected and consumers can get to the historic data in order to see their consumption back into weeks, months, years before. So there are two opportunities for consumers, either to connect directly to the meter. I think it was already shown also by Davy in his architecture. It's called the P1 interface, for example. That's used in Belgium and the Netherlands at least, but at least it's called P1 in Belgium and the Netherlands. In other countries, the interface has another name. So there is this interface, and then there is this internet possibility to download data from central servers. Second question was, can meters can be made without a display? There is always a display on the meter itself, so not connected to the meter, but on the meter, and that's a legal requirement. The Measurement Instrument Directive in the European directive requires meters to have a display, so consumers can always check the consumption figures on the meter itself. So that's a legal requirement. We cannot delete that display. But again, there are additional ways to get to the data. And again, getting back to the reports that I have shown in the beginning, it's a good overview of where these interfaces are implemented and what are the standards that are used for this interface on the meter itself. I don't know if any one of you would like to add something to that before we go to the next question. If not, then we go to question number 4. How is interoperability ensured when parts of the meter are undoing ad hoc over the air or are doing ad hoc over the air upgrades? In other words, must the legacy of the past always be supported? I think that Davy already indicated that he would like to start off with answering this question.
Yes, so it's a question mainly about how to handle, let's say, install devices, the legacy. I think our experience also shown, having carried out multiple pilot projects, that at some point as a DSO, you have to take decisions to leave the past behind. It's really not advisable to create something which is backwards compatible with everything you've done before, because making it, I am trying to achieve this backwards compatibility, decreases your future possibilities, because there are also, for example, on security related matters, it will make things more complex and it will hinder you into realize certain things. Our approach in that as Fluvius is to really look at it population based, and with population I mean, okay, which type of meters, which type of customers are impacted. Look at the install size of that. How many customers are you talking about for which kind of service or business use case? And based on that, take a decision. If the population is limited, maybe you have to call a replacement program and to earlier than planned replace these older type of meters to keep your new solution as easy as possible. Don't overload it with the legacy from the past, and dare to take decisions, replacing it earlier or not offering new types of service. For example, you might think of new types of meters, for example, for the electrical vehicle setup. Not today, in the coming years. Okay, there will be an increase, but not every household immediately has an electrical vehicle at his house. So segment your population, segment your customers, and take asset decisions based on that would be my advice.
Good. Any other additions to this response?
Yeah, maybe just we touch on the point of firmware upgrades and the ability to at least keep everything relevant from your installed base. So that's clear, both at the battery part or the sub-metering devices as well as the main device. But maybe just another quick point to note. There's lots of innovation coming from the energy services company perspective and the retail perspective. And it's sort of back to the previous point as well. The current specification allows the device itself to push information to the end customer on a very low, on a very regular basis, 15 seconds, 10 seconds, that type of basis, adjustable. So, and that information could be everything from voltage information to energy information to profile information to maximum demand at that point in time. That allows other players to actually interact with a device that is supplied by a grid operator, which will be in the ground for 10 to 15 years, but will still remain relevant and providing new use cases for other players to interact with that same device. That structure allows for to a large extent for a lot of future-proofing in terms of enabling things like what David mentioned from an electric vehicle perspective, or things like heat pumps, demand response type of applications. So beyond the grid operator, using the same architecture, the same use case infrastructure that's being invested in now for new players to enter the market and to be able to offer new innovative things by leveraging the existing investment. That I think is a key part to retain. And yes, to that extent, that means that not everything from the history could and should be incorporated. And somewhere there should be a line drawn. We believe the line currently in the sand is pretty effective to address the future needs of the utility and other players in the industry.
Good.
Right.
Thanks, Peter. Any other additions? Okay, then we go to the next question. Our presentation was very focused on the meters, but the good design of use cases is a part of the design of the meter data management system. So how are meter data management systems specified in the Fluvius project? So I'm afraid, Davey, this goes to you again.
No problem. Indeed, we didn't go into details on the central IT systems like the MDMs today. It's maybe a possible topic for one of the future sessions at Enlit. But we touch already, in fact, on the point. It's for us, it's decoupling the layered approach of the standards. DLMS as such, because the electricity meter is the main communication hub, using the DLMS is the de facto standard on this. And we also see on the side of the MDM systems, the data model being incorporated there. So we really worked starting off the DLMS data model, but like Peter and the colleagues touched in the beginning, the extra decisions we have taken thanks to IDIS, thanks to OMS, really make that the data model which we have in place is fixed, is structured, and can be used. And that was really our base to build the MDM system and to continue with growing. It's not so that. In fact, it's the DLMS data model which is dictating the data structures towards MDM. And it's not any, call it fancy IT invention or of IoT, whatever cloud solution which came up with new data models. No, we stick, DLMS is at the driving force to determine this.
Okay.
Maybe Tony or Peter, if you can contribute to that.
Yes, I'll just say that obviously the DLMS standard, the core standard, is forever evolving, and new features, new functions, new use cases are always being incorporated into the standard by the membership. And the good thing about having that standard as the core of your MDM data model is that no matter what use cases you need in the future, be that with demand response or with electric vehicles or whatever you need to manage, then the same data model can then expand to incorporate those new use cases as and when you need them, and those can be then built into future interoperability profiles and certified in that way, without having to completely redesign for a new application layer protocol within your head-end systems.
Right. I think also just a comment from a sort of the northbound systems, things like MDMs and even beyond that, data hubs that are emerging in certain countries or certain geographies. There's very much a trend in the market, and it's a global level really, towards standardization in that domain as well, where DLMS goes and where objects, the data coming from the devices itself, is transformed into the common information model, the SIM model coming from IEC 61968. So that's a pretty complete model when we start looking at modeling the operations of a utility, and ultimately there's a de facto standard emerging where that's the data model of choice for northbound systems like the MDM. So practically, the head-end system will transform the data into a SIM-based description, which will go to your northbound systems, whatever that systems would be, a data hub, an MDM, or other corporate systems.
Okay, good. I think we still have time for a last question. And that's one I would like to ask Charles. So battery lifetime, that's one thing. We have discussed the protocols, the standard protocols, and the data application layers. They put of course what some requirements on resources. Same, I think, with security requirements that also might again be requiring more capacity. So what does it mean for non-electricity meters, the gas, the water, the heat, etc., on battery lifetime?
Well, in fact, Willem, the battery lifetime has been an issue in the past. But since investigations have been made in the early 2010s, showing that the quality of the battery and capacity of the battery was in fact in practice not a problem. When there was a drained battery, it was always the electronics that drained the battery, and it was not something else. Battery has now become really a standard for sub-metering, and wireless is what we can see everywhere and has very dominating on the, let's say, the wide solutions. We can see that in more and more tough conditions, battery can last longer. We are also supported by the manufacturers of the battery manufacturers, and they do so. There is plenty of choice of good batteries, and in fact, it's not an issue anymore to guarantee a meter for 15 years battery lifetime or even more. Then, at the other hand, the OMS is working very much in the standard to enable the decrease of needed capacity, and that so that helps each other very well. I think on today battery is still gives a limitation, but is extremely fit for multi-utility projects as these. When we go to point-to-point communication, battery is still a limitation, and we can see that all over the place, that where we have point-to-point communication combined with battery, that we have a limited lifetime, and we have increasing service cost to maintain battery capacity. Is this an answer on your question?
Yeah. Thanks, Charles. Good. Yeah. Looking at the time again, I think we have to slowly start to wrap up. First, let me thank the speakers and panelists again, Peter, Charles, Tony, Davey, for their contribution. I just would like to take shortly the time to come up with some key takeaways that I have made note of during the session, and let me start with first what came out of the discussions is that technology developments and projects in smart metering area have created a valuable history of best practices that can be used for other approaches of interoperability for smart grids and a wider scope. So we have seen that a lot of groundwork has been done in the metering area that is a good basis and good best practice to be used in other areas. And second, more steps than just selecting a standard are needed to reach interoperability, such as defining the use cases for data transactions and conformance testing. IDIS and OMS and the DLMS User Association are providing solutions for these steps, and we have seen that Fluvius has been using them extensively. Then multi-utility approaches are seen to be or have proven to be very efficient by using a general infrastructure for multi-purpose applications, saving substantial investment. And then finally, we have also heard that Internet of Things and 5G technologies can be and are being integrated in the existing standards because network and application layers are decoupled to make this possible. So yeah, that's my takeaway. I would like to turn to Areti back again and to let us know if we can finish or still things to be done, and also maybe give your conclusions, Areti.
Yes, thank you, Willem. I appreciate it. Thank you to everybody. I heard that you had some takeaways from this this episode, this very, very interesting episode. I just wanted to ask you, if you were to take only one thing with you at ESMIC, which one would you choose? Which takeout from this session?
Yeah, that's the thing that I started with. So really is the conclusion that just selecting a standard in order to reach interoperability is not enough. We need use cases that describe the data transactions. We need testing procedures in order to check if products comply to the standards, interoperability testing in order to test a complete infrastructure. So all that stuff has been done in metering projects. Solutions are provided by the associations that we have seen today. So that would be my key takeaway.
Perfect. I couldn't agree more. Thank you very much, Willem. On behalf of Enlit Europe, I would like to thank today's panel for sharing their valuable insights with us. I'd like to remind you that a recording of today's webinar and the other webinars in this virtual series will be available on demand on the Enlit Europe website. Join us on the 15th of September for a new episode of the Enlit Europe Data Hub series. It will be focused on smart metering, the EU landscape, and it will take place in the morning at 10 Central European Time. Again, thank you for joining, and until next time, stay safe.